Hello learner, welcome to Manifested e-learning platform. My name is F.A.M. Lingwiri and I practice within the financial services industry in Kenya. Today we are going to conclude this topic on capital market theory. So this is the unit under the Cifa qualification. The topic on capital market theory, we are going to conclude that by assessing or analyzing active risk, tracking error, and information ratio. So we start off by saying, or by mentioning, what active return is and what active risk is. So active return, we say, refers to the differences in returns, refers to the differences in returns between a managed portfolio and its benchmark. A managed portfolio and its benchmark. Take, for example, we are using the benchmark as the NSE 20. It generates a return of X. Then we have our hypothetical portfolio, that we have allocated specific weights to specific asset classes. We get return. Why? So we're saying the active return is just or refers to the differences in returns between a managed portfolio and its benchmark. So we just say Y return minus X return, and that gives us active return. Moving on, we can say that active return is therefore return on the portfolio minus return on the benchmark. RP portfolio return, RB benchmark return. So that is it, active return. What then is active risk? So we say active risk, active risk there. We can also say is also termed as tracking error, tracking risk, brackets, tracking error, stroke, tracking risk. There. So we extend that line until there to refer to it as the same thing. Is the standard deviation of active return. Is the standard deviation of active return, is the standard deviation of active return, So we dive right in to the formula. It is given as follows. We can come on this other side. We're not too supposed to strain as analysts or as experts in the financial services. So active risk is given as standard deviation of return on the portfolio minus return on the benchmark, subscript, which then is can be expounded as follows: as return on the portfolio minus return on the benchmark divided by n minus 1, where n is the number of periods. Return on the portfolio, we already defined that there, return on the benchmark. So this is what we're saying is active risk, standard deviation of active return, like that, standard deviation of active return. Standard deviation of active return is what is termed as active risk. So we can say that the active risk of a portfolio can be separated into two components, full colon there. Number one, active factor risk, and we are saying is attributable to the deviations, is attributable to deviations of the portfolio factor sensitivities of the portfolio factor sensitivities versus the benchmark versus the benchmark sensitivities to the same set of factors, The active risk of a portfolio can be separated into two components: active factor risk, which is attributable to the deviations of the portfolio factor sensitivities versus the sensitivities of the benchmark. So there's benchmark sensitivities to the same set of factors. The second component, number two, active specific risk. Underline it for consistency. You put a hyphen and say risk from active asset allocation, risk from active asset selection, active asset selection, risk from active asset selection attributable to the deviations, attributable to the deviations of the portfolios individual asset weighting, individual asset weighting versus the benchmark versus the benchmark's individual asset weighting, after controlling for differences, controlling for differences in factor sensitivities, factor sensitivities. Factor sensitivities, we can say of portfolio versus the benchmark. Of portfolio versus the benchmark. Versus the benchmark. Versus the benchmark. Let's review what we've just written there. There are two factors, active factor risk, active specific risk. We're saying that risk from active asset selection attributable to the deviations of the portfolio's individual asset weighting versus the benchmarks individual asset weighting after controlling for differences, because there'll be differences in factor exposures or factor sensitivities of portfolios versus the benchmark there. So having discussed that, then we can move over on this other side and discuss something else. The sum of active factor risk, ladies and gentlemen, the sum of active factor risk, the sum of active factor risk and active specific risk, active specific risk is equal to active risk squared, active factor risk plus active specific risk, So this is a very important equation right there. You're saying that the active risk squared is active factor risk plus active specific risk there. So we discuss an example. The example that we are going to look together is December 2017, question 1D. Question 1D is what we're going to discuss. Hope you have your question bank, and I will read for you the question. The table below shows the portfolio return and benchmark return for a bond portfolio over a 6-year period. So you have the periods given to you, or the period given to you there, 2011 through to 2016. Portfolio return, as returns have been given, the benchmark returns have been given. Required, they want you to compute the portfolio tracking risk there. So the first thing that we need to do is to first of all write down in form of a table, if you wish, to draw it in form of a table so that it can easily be analyzed and assessed there. So let's do that right away. So what I need is, I need at least some space on this side. So I need this space over here so that we can be able to draw that table together. So December 2017 1D, we start by mentioning the period. So I hope you're focusing, you're concentrating. So period there. Then we can see the portfolio return and the benchmark returns has also been given. So portfolio return, benchmark return has been given. They have all been given that. And what we need to do, ladies and gentlemen, the first step is to compute the active return, because you already know what active return is, what active risk is, and that's what you're saying that we need to compute. So the active return is just given as the return on the portfolio minus return on the benchmark. So active return. So RP, so I can put it in probably maybe a different color so that it can be able to showcase the formula how to get. So RP minus RB. Once we have that, then we proceed on and get the active return. Then we get the active return minus average active return, like that. So active return less average active return. That's what we need. Active return minus average active return. Once we have that, we need to get then the active return less average active return squared. So active return minus average active return. This should be squared like that. Putting it all together like that, we can then put in the period, ladies and gentlemen. So it's 2011 running through to 2016. The portfolio returns have also been given. Portfolio return is 14.1. Then we have 8.2. Then we have 7.8, 3.2. Then 2.6 and 3.3. So of course, these portfolio returns are expressed in percentage form. Even the benchmark return is also expressed in percentage. So for convenience purposes, let me just indicate that there are percentage there at the top. It refers to that column. So the benchmark return is 13.7. 13.7. Then we have 8. We have and then 8 again, 8 and 3.5, 8, 3.5. Then we have 2.4 and 3, 2.4 and 3.0, like that, or 3, because we've not put points for these ones here, so it's 3, just like that. How do we get the active return? Return on the portfolio minus return on the benchmark there. So we pick the calculator right here. Return on the portfolio minus return on the benchmark. So we have 14.1 minus 13.7, 0.4. So now we can start populating with a different color if you don't mind, guys. So we have 0.4 because that represents what you need to compute. Then we have 8.2 minus 8, so that's 0.2. 7.8 minus 8, we have negative 0.2. Then 3.2 minus 3.5, that's 0.3, negative 0.3. And then 2.6 minus 2.4, we have 0.2. And finally, 3.3 minus 3 is 0.3. Active return, ladies and gentlemen, you are required to get active return minus average active return. So that means we need to get the average active return. We add all this and then we divide by the number right there. So we're saying we have 0.4 plus 0.2 minus 0.2 minus 0.3 plus 0.2 plus 0.3. So we get 0.6. So the summation over here is 0.6. So summation is 0.6, like that. Once we have 0.6, then we need now to get the average. 0.6 divided by 6, ladies and gentlemen. 0.6 divided by how many periods? 1, 2, 3, 4, 5, 6. So 0.6 divided by 6, like that, we get 0.1. So on this further end right here, guys, I hope you're going to pay attention. On this other end here, I want us now to, of course, explain how we got the values. So we are saying the average active return over there is given as, we'll add all this, 0.4 plus 0.2 minus 0.2 minus 0.3 plus 0.2 plus 0.3 all over 6. And here we are getting how much? 0.1. That is the average active return. So you say active return, which is 0.4, minus average active return, which is 0.1, like that. How much do we get? So that's what we are going to be getting through this column right over here. 0.4 minus 0.1, 0.4 minus 0.1, we get 0.3. Then 0.2, 0.1, of course, that's going to be 0.1. Then negative 0.2 minus 0.1, we get negative 0.3. Then negative 0.3 minus 0.1 is negative 0.4. And then we have 0.2 minus 0.1. We have 0.1. Then here we have of course, 0.3 minus 0.1 is going to give us 0.2, like that. Once we've generated this column, you can see here active return minus average active return squared. So we just square what we have over here to get absolute values. So it's going to be 0.3 squared, we just get 0.09. Then 0.1 squared will just be 0.01. And then this is going to be 0.09, obviously, because it's going to be an absolute value, 0.09. Then 0.4 squared, of course, is going to be 0.16. 0.1 squared is going to be 0.01. Then 0.2 squared, this gives us 0.04. So once we have that right there, we know the formula that tracking risk gives us the sum of the deviations, the sum. So we sum up this part right over here. We sum up all of this. How much do we get? We need to get the calculator. Sum of squared deviations, so tracking risk is given as square root sum of deviations all over n minus 1. That all over n minus 1, ladies and gentlemen. So that's what you need to try and focus on. So sum of deviations is these ones. Yeah, so we just add them. 0.09 plus 0.01 plus 0.09 plus 0.16 plus 0.01 plus 0.04. 0.4. So which is 0.4 divided by n is the number of periods, 6. 6 minus 1, and we get the square root of that. So which is going to be 0.4 divided by 5. Divided by 5, which is saying 0.08. So square root of 0.08. So square root of answer 0.2828. 0.2828. That's what we are saying is the tracking error. 0.2828%. In fact, it should be percent. Right over here, it should be a percentage like that, because you're saying it's a measure of risk, the percentage exposure towards risk the ability of the portfolio to deviate from the returns of the benchmark. So having discussed that, over here we can move over on this other side, ladies and gentlemen, and we proceed on with the information ratio there. So I'll just pick the duster right here, and that is December 2017 1D. We can just rub right here. Information ratio is usually a performance measure that is used within the investment industry to try and evaluate performance. So it's performance evaluation technique there. So just do it like that. So information ratio. We are saying the information ratio is the ratio or the performance measure which is the active return per unit active risk, per unit active risk. And so we're saying that the information ratio is given as active return divided by active risk, which you're saying is return on the portfolio. Active return is return on the portfolio minus return on the benchmark divided by the standard deviation of returns between portfolio and the benchmark. So subscript RP minus RP. That's what we're saying is the information ratio. And the best way to demonstrate its application is by looking at an example. So the example reads as follows. Assume the portfolio and the benchmark returns over the past 12 months have been shown in the following table. So you can see the table is provided for you right there. The months have been given up to 12 months. You've been given the return on the portfolio, and you've been given the return on the benchmark. Given the data in the table, calculate and interpret the manager's information ratio. So the information ratio is just given as the return on the portfolio minus return on the benchmark, and then we are saying that the return on the portfolio minus return on the benchmark divided by the standard deviation of returns right there. So that information over there given to you is straightforward. There are times that they could be able to give you the return on the portfolio only, the return on the benchmark. So what you're supposed to do is that you're supposed to get the return on the portfolio minus the return on the benchmark like that, and then you get the sample standard deviation. So in this case, we've been given the sample standard deviation, and we can be able to compute it very easily. So the information ratio right there, information ratio is given as, in this case, RP minus RB all over standard deviation of RP minus RB. That, which we're saying is given as the return on the portfolio minus the return on the benchmark. You can see it is 0.0, the return on the portfolio, the sum of it is 0.0076, like that. Then minus the return on the benchmark. The return on the benchmark is 0.0059 given to us over there. Then we divide by the standard deviation of returns between the portfolio and the benchmark. So in this case, we're getting the sample standard deviation of 0.0063 like that. So how much do we get as our information ratio? 0.0076 minus 0.0059, and then we divide that by 0.0063, I am getting 0.27 there. So I'm getting 0.27 like that. That is the information ratio measure there. So what does this mean? The higher the information ratio, guys, the higher the return the manager has earned per unit risk. The higher the return the manager has earned per unit risk. So we are saying what? We are saying that the manager managed to get 0.27 or 25 basis points of active return per unit active risk. I hope you have understood how we can be able to compute the information ratio like that. So this brings us to the end of this topic on capital market theory. We hope you have enjoyed it, and I will leave you with an assignment as usual on this further end over here. So the assignment. So of course I will derive the assignment from the Manifested Publishers book over here. As you can see, this is the portfolio management revision partner, ladies and gentlemen. Over here you can be able to clearly see it very well, and with this you will be able to at least recipe for success is here with Manifested Publishers, because we are here for you. And the question that I want you to look at, or the questions that I want you to look at, is May 2017 5B and C, May 2017 question 5B and C. Then the second part, the second question that I want you to look at is September 2015 2A, September 2015 question 2A, and finally from the book I can actually see right over here that we are getting something to do with May 2018 3D. May 2018 question 3D. Thank you for being with us, and be blessed.